part in the discussion here. All right, if you can't write all this down so fast, I promise I'll put it up today. Okay, those other two lessons are already up there. Okay, so let's do a little bit of talk about review on the left-hand side. So, in what cases of a triangle, given sides and angles, which are the cases when you use the law of sines? So a little bit of review from last time. Does anybody remember? When do you use the law of sine? When you're given, what are the possible scenarios that you can be given? Not including the ambiguous case. Angle, side, angle. Yeah, there you go. Angle, side, angle. Or what's the other one? Yeah, angle. Or how about angle, angle, side? I was going to save that one for this one down here, right? When you're given the ambiguous case, that's when the angle side said. That's bad, right? When you're given the angle side said. All right, what are the three possible outcomes when you're dealing with the ambiguous case? You could have three things that could happen. Give me one of them. You could have no triangle that exists, right? Give me another one. You have one triangle that exists, or you can have two triangles that exist, and this one is the bummer. Ugh, that's the one that takes more work, right? We don't like that one, but it can happen. All right, so that's when you use the law of sines. You use the law of cosines when you're given something else. Use law of cosines in either of these two situations, either side angle side or situation number 2, side, side, side. That's when you use the law of cosines. So we use this when we're given these two situations. Use the law of sines when you're given these two situations. So you got to know which one is which. So we'll draw a triangle out just like the book does. And this is A. Then across from A is going to be our alpha. Oops, that's not alpha. Leah. All right. If this is B, then what's this one over here? That's our beta. And if this is C, then this has to be our lambda on the other side. Okay? So notice we have 3 sides and we have 3 angles. All right? For the law of cosines, the way that I set it up is you can either solve for the sides or you can solve for the angles. And I'm going to show you each one. And there is a trick to remember how these go. And I think after the first one, you'll see it, okay? So let me give you the equation for the law of cosines for finding side A. So it's going to look like something like this. A squared is going to be B squared plus C squared minus 2BC times the cosine of alpha. Now, I know what you're saying. That looks really scary, but watch this. I'm going to give you an easy method to remember it. A squared, or A is always across from which angle? Alpha, so the ends have to match. What are the only other 2 sides of the triangle? B and C, and those have to match. Oh, all of a sudden, everything else stays the same. Watch this. If I want to solve for B squared, then it's going to be A squared plus C squared minus 2AC times the cosine of which angle is across from B? Beta. There you go. There. So we've got a B here, and we have beta there. And look, the other 2 sides that we have not yet used are right there and right there. That's pretty easy, right? I think it's pretty easy. So can you guys figure out what the last one will be? Yeah. There you go. A squared plus B squared minus 2AB times the cosine of gamma. So again, right, our side is always opposite our angle, and our 2 other sides that we have not yet used appear simultaneously inside the equation. And notice what I mean by when they're all solved for sides. Notice that these are all sides. Side A, side B, and side C. That's what I mean by solved for sides. Okay? But we could also solve these for angles. And here's how it would work. Okay? If I want the cosine of alpha, it would be A squared minus B squared minus C squared. I just subtracted B squared and C squared from both sides, right? Then to isolate my cosine of alpha, what would I divide by? A negative. No? 2BC. Yeah, there you go. If I want to isolate the cosine alpha. So all I did was solve for cosine alpha on the right-hand side. We're going to do the same thing with for beta. So if I want the cosine of beta, it would have to be b squared minus a squared minus c squared divided by what? Negative 2ac. And of course, if I want the gamma, then cosine gamma has to be c squared minus a squared minus b squared all over negative 2ab. Now, you don't have to have those memorized. Okay? You can put those on your card. But there is a trick to helping you remember which one is which. And most of the time, you're going to be solving for sides, and you'll be able to use deductive reasoning to get the other things that you need. Okay, so there's the whole setup. Let's do 2 examples, and that's it, okay? So we're going to solve this triangle right here. I'm going to give you some information about this triangle. I'm going to say that A is equal to, I can't remember what I did. Oh, 2. B is going to equal 3. C is going to equal, I don't know. Alpha is going to equal, I don't know. Beta is going to equal, I don't know. And gamma is going to equal 60 degrees. All right. So here's what we do. We have to go straight to a sketch because we don't know what type of a triangle we are dealing with here. All right. So here's our sketch. Here's what we know. If this is 2, then what's across from the 2? The alpha. Good. If this is 3, what's across from the 3? The beta. Good. And if this is C, what's across from the C? Gamma, which is 60 degrees. So notice, everybody, I have a side, angle, side, triangle. I have side, angle, side. That implies I use the law of cosines, LOC, law of cosines. Got it on lock. There you go, right? So I need to get this side first. I need to get C first. Okay, so I want C. So I go back up to my equations here, and I see that I'm going to use this formula because it's already solved for C. You guys get it? You with me so far? Okay. So here's what it says. It says that C squared has to be 2 squared plus 3 squared minus 2 times 3 times the cosine of the one that's opposite, which would be 60 degrees. Now here's where students make a big mistake. They put whatever answer is here. They put a 2 there, and then they put a 2 over there, but really, when we actually work this out, C squared, this is going to be 4 plus 9 minus 2 times 3 times the cosine of 60 degrees. So do you see what I'm saying? They will accidentally put a 4 where the 2 is. You guys see what I'm saying? No, you're not seeing what I'm saying? It's a common mistake. It happens every single year, okay? So I'm just warning you guys about it. Yeah, you'll be that guy. Okay, so your goal is not to be that guy. Okay, so 4 plus 9 is, what is that, 13, right? Minus, let's see here, 2 times 2 is 4 times 3 is 12 times the cosine of 60 degrees, and the cosine of 60 degrees is a half because we all have that one memorized, right? Yeah, I know you do. So that means I'm going to have 13 take away 6. So C squared must be 7. So that means that C must be the square root of 7. Now, of course, we take the positive one because, after all, we're dealing with the distance here. So this must be the square root of 7. And we just keep on going along. All right? We have to get alpha or beta. Doesn't matter which one we get, because once we get that one, we're going to subtract from 180, and we'll automatically have the other one. So which one do you guys want to get? Alpha. Okay, sweet. Let's get alpha. So let's go back over here, and notice that I'm going to use the alpha formula, right? Cosine alpha, a squared minus b squared minus c squared. Let's do that. So the cosine of alpha has to be a squared minus b squared minus c squared all over negative 2bc. Is that right? Let's double check. Yep, that's right. So therefore, the cosine of alpha must be a squared is going to be 4. Is that right? Help me out. Help me out. Yeah. Okay, 4 minus 9 minus 7 all divided by negative 2. No, isn't it squared? Right? minus 2 times 3 times 2. We all doing good so far? Okay, therefore, cosine of alpha is, what is all this stuff? Correct, but rad 7 squared is 7, right? Oh, it should be minus 2 times b times c. Minus 2 times b. Oh, thanks a lot. So this part down here should be a rad 7. I'm with you. Thank you. Nice catch. Way to go. So let's hear 4 minus 9 minus 7. How much is that? Negative 12? Is that negative 12? Negative 12 divided by negative 6 square root of 7, which is just 2 divided by the square root of 7. Okay, so cosine of alpha equals 2 over the square root of 7. How do I get the alpha? There you go. Inverse cosine 2 divided by the square root of 7. So alpha should be, okay, plug that into your calculators and tell me what you guys have for inverse cosine of 2 over square root of 7. 40.9 degrees. That's what I got to. 40.9 degrees. Great. Now we go back up, and we know that alpha is 40.9 degrees. How do I get the beta then? The easiest one of all. That's right. So it's just 180 minus 60 minus 40.9, which is how much, Riley? 79.1 degrees. And ladies and gentlemen, we've now solved the triangle. We have all 6 parts. Why is it taking so long? Okay. So this is your neighborhood. All right. This is your neighborhood. And it's a nice neighborhood. You live here. This is where your house is. It has a pool. It's got a pool table for you. This is where you live, okay? This is where lives. Hey, Bill. Friend Mark lives. Okay? You guys counted. You know how far it is from Mark's to your house? Turns out it was 823 feet. You know how far it is from Bill's to your house? It was less than that. 547 feet. What I want to know is how far is it from Mark's house to Bill's? This. Well, you do have to know an angle of here, right? An angle separates the two. And the angle that separates that two is less than 87 degrees. Can you guys see that at all? No, you can't. Not at all. Yeah. Whoa. Oh, this is what I want. This is the one I want. Hold on. It's coming. Yeah. Oh, yeah. Yeah. See? Much better. Oh, there it is. Period. Okay. All right, guys, later. I'll put